Hello, welcome to Project 152. This is week 15. Now, every week we go through a few more questions from the QCAA. If you stick with it for the whole year, you'll have done every single question that the QCAA has ever done. Now, before we kick off, I want to say a big happy birthday to Jess. Jess, one of your friends, Rosie, has dobbed you in as an avid watcher of Project 152, so I hope you're watching today. Happy birthday. Let's go. Okay, so here we have consider the proof. We're talking proof by induction. Now this is an interesting one. I hadn't seen one like this until 2023, which is where this question's from. An appropriate assumption statement within the proof is. Now an assumption statement is where you assume that it's true for K. But you've got to be really careful here because you can see this R stuff here and you can also see N here. So what are we substituting K in for? Well, it's only this N that we're substituting K in for. So let me write that down and then let me explain. So this is the statement and you can find it in here. We'll circle it in a second. But the reason, why are we not making R equal to K? Why are we making N equal to K? Well, you've got to understand what this statement says. This statement says, starting at R equals 1, do this and then do R equals 2, and then do R equals 3, and then do R equals 4. Add all of those together until you get up to the kth value, right? And so when we're doing proof by induction, we want to show that it's true up to some unknown k value. This R is just where we're substituting everything in, but this value, all of these n's, this is whatever iteration of this partial sum we're going to get up to eventually. So you've got to be very, very careful that you understand what you're saying here. This is 1 times 1 plus 1 plus 2 times 2 plus 1 plus 3 times all the way up to k times k plus 1. All right, so where's our answer? Our answer is C, celebration. Next question. All right, so this question's interesting because I think we can do it two different ways, and I think I am going to do it two different ways, and then you can pick which way you like doing it better. All right, so one solution of this cubic is z equals negative 2. Now, if z equals negative 2 is a solution, that means that z plus 2 is a factor, right? If z plus 2 is a factor, z equals negative 2 is a solution, and vice versa. All right, so now that we know that, because we need to know that for both methods, we're going to start on our first method. So I've just rewritten by cubic here, and now that I know that z plus 2 is a factor, I can say that this is equal to z plus 2 times some unknown quadratic. Let me tidy that up. So now that I know that this is equal to this times an unknown quadratic, if I expand all of that and then equate coefficients, I'll be able to find my answer. Now I won't make you watch me expand all of this, but it's going to be this times this, this times this, this times this, and this times this, this times this, and this times this. Now this is the part of this question where people have a little bit of trouble. Look for all of the z cubes. You can see we only have one of the z cubes, so that's a z cubed, right? And then look for all the z squareds. I can see one here and I can see another one here. So that's z squared. And then I can factorize that, b and 2a. Okay, and now look for all the z's. There's a CZ and there's a 2BZ. So Z, C plus 2B. And then finally, way down on the end here, there's this 2C. Okay, now we can do that thing that I was talking about, which is called equating coefficients. So, if Z cubed minus Z squared minus 7Z minus 2 is equal to az cubed plus b plus 2az squared plus c plus 2bz plus 2c, we can take a look first at the z cubes. And we can say, okay, there's a 1 there, so therefore a is equal to 1. Okay, now that I know that a is equal to 1, I can rewrite this putting one in wherever I see A. So I can see an A here and I can see an A here. That'll be useful. Now, probably the next easiest one to do is this one here, -2. We can see that -2 is equal to 2c. So maybe just a little bit of working we'll need to do there. -2 is equal to 2c. That means that c is equal to -2 divided by 2, which is -1. Great, I know that c is equal to -1. Why don't I, everywhere I see c now, there and there, just scrub out c and replace it with -1. Now finally, it doesn't really matter where you look for the next one, but there's two places you can look. We've got b plus 2, and b plus 2 must be equal to -1. Or you can say -1 plus 2b is equal to -7. Now, if I've done this correctly, it really won't matter which one I do. So let's do this one. b plus 2 is equal to -1. And that means that b is equal to -3. And again, I can double check this because if I've done it correctly, -1 plus 2b is equal to -7. -1 there, -6. 2b, b is equal to -3. Okay, good. It worked there, it worked there. So what does all of this mean? It means that z cubed minus z squared minus 7z minus 2 is equal to z plus 2 times not az squared plus bz plus c, but az squared, so z squared plus bz, b we decided was -3, -3z, plus c, which is -1. So do I have a z squared minus 3z minus 1? Z squared minus 3z minus 1 equals 0. If I solve that, z squared minus 3z minus 1, I'll know what my two solutions are. All right, this is a really good way to do this question. This is the way that I recommend you do this question. If you want to fast forward to the next question, you should, because the other way to solve this question, which I'm going to do now, is polynomial division. So I can kind of kick off from this same idea. The cubic is equal to the linear factor, which we figured out from up here, z plus 2, and then this az squared plus bz plus c. But if this is equal to this times this, then that means that if I divide both sides by z plus 2, if I divide this side by z plus 2, if I divide this side by z plus 2, all that'll be left is whatever that is. So in other words, I'm going to take this cubic and divide it by z plus 2. Okay, so z cubed divided by z is z squared. And now I take that z squared, multiply it by z, which gives me z cubed. And then take the z squared and multiply it by 2, which gives me 2z squared. And then I subtract one of these from the other. That's always going to be 0 if you've done it correctly. -z squared minus 2z squared, so that's -3z squared. Okay, -3z squared divided by z is -3z. -3z times z is -3z squared. -3z times 2 is -6z. Okay, and we can kind of bring that -7z down now. Subtract one from the other. If you've done it correctly, these will cancel out. -7z minus -6z, so -7z plus 6z gives us -z. Bring this one down, -2. And then finally, -z divided by z is -1. And -1 times z is -z. And -1 times 2 is -2. Subtract them from each other. If you've done it correctly, you'll end up with a 0 here. If you've done it incorrectly, you won't. That's another way to do it, and you can see here is my answer. Now, I've moved through this very quickly. Either you're comfortable with polynomial division, or this is the first time you're seeing it. If this is the first time you're seeing it, you can look me up. You can find a video of me doing it. I don't love this idea. I don't love doing it this way because it's very algorithmic. Students, teachers don't really know how this works. They just go through the steps and it does, right? As soon as a question is not a simple multiple choice question like this, it's something like different, left of center, and they always put like a weird, complex, unfamiliar question at the end that's got something to do with this kind of thing. Polynomial division is going to let you down. Equating coefficients is a really powerful tool that you can use with like a whole variety of ideas. So keep that in mind. Not recommending this, but I thought I'd put it in there. Celebrate. All right, so we've got a neat little partial fraction style question here. The integral of this, and we're told a little bit of information there, which is going to be super useful. And then we're told how we need to express our answer. Very important to follow those instructions. All right, so it is a partial fractions question. So first of all, we need to look at this and be able to break it up into partial fractions. We don't even think about integration until we've done that. All right, so there is my beginning part. That's just the fraction, x squared minus x minus 6 on the bottom, 4x minus 17 on the top. Now, I really need to factorize my quadratic. And thankfully, this little bit of stuff, that's a clue, right? Because the factorization of this is x plus 2, x minus 3. The reason they have to put this in there is because the integral of this doesn't exist when x is equal to negative 2, because the denominator ends up being 0. And it doesn't exist when x is equal to 3 because the denominator ends up being 0. So you should be able to factorize that pretty simply with like stuff you learnt in grade 9, grade 10. But also, I was given a little hint here so I could factorize it like straightforward. I can also expand it at the end to make sure I'm right. Okay, if we have done this, we can now say that that's going to be equal to a over x plus 2 plus b over x minus 3. And we can then condense that back into a single fraction by multiplying this one, top and bottom, by x minus 3. So we get a x minus 3. This one, top and bottom, by x plus 2. So we get b bracket x plus 2. And the whole thing is over x plus 2 times x minus 3. Now we've gone backwards and forwards, but the reason we've done it is because on the left-hand side, we have 4x minus 17 over this, which is also this. X plus 2, bracket, x minus 3. Which, of course, means that if the denominator for x plus 2, x minus 3, x plus 2, x minus 3, we can multiply both sides by that denominator, and we're just left with the very clean 4x minus 17 equals a bracket x minus 3 plus b bracket x plus 2. Okay, now that we've done that, this bit here, we need to figure out the values of a and the values of b. And to do that, all we need to do is substitute some like helpful values of x, right? If I substitute, because x can be anything, because this is a function, so x can take any value here. If I let x equal 3, right, then we'll get 4 times 3 minus 17 equals, and then this 3 minus 3 is 0, so this whole thing becomes 0, and then I'm left with b bracket 3 plus 2, which is 5. Alright, so that means that 12 minus 17 is negative 5, and b5, 5b, which means that b is equal to negative 5 divided by 5, which is negative 1. Okay, we can do the same thing again, but put in a useful value for x to make this b disappear. And the useful value for x would be negative 2. So, doing this again, we get 4 times negative 2 minus 17 equals a negative 2 times negative 3, which makes negative 5. And then this is 0. So we're left with negative 8 minus 17. Negative 8 minus 17. That feels like it's going to be like negative 25. Negative 5a. A is equal to negative 25 divided by negative 5, which is 5. Great. I know that a is equal to 5. I know that b is equal to negative 1. I've done that partial fraction thing. And when I say I've done that partial fraction thing, I can rewrite the integral that we started with, 4x minus 17 over x squared minus x minus 6 with respect to x. And now I can rewrite it as our two fractions. A over x plus 2, but a is actually 5. So 5 over x plus 2. And then b which is -1. So I can put instead of putting plus -1, I can just put minus and then 1 over. So we're pretty close to a solution now. We need to integrate this, and we need to integrate this. Now, partial fractions, you should have practiced them enough that you can straight away look at this and know that the integral is 5 ln absolute value x plus 2, like that. And then minus 1, we don't need to write that, ln absolute value x minus 3. And then, of course, we're integrating, so don't forget our little plus c on the end. Now, double check we've got a problem because we need to express our answer in this form. We're not in that form at the moment. We've got a natural log here minus another natural log there. So how are we going to get into the form we need to get into? We're going to have to think log laws. So first of all, I'm going to take this 5 and bring it here to the front, to the back, I guess, as a power. So ln x plus 2 to the 5. And then subtract ln x minus 3 plus c. And then I can use one more log law because I have this negative here. So I end up with ln absolute value x plus 2 to the 5 over x minus 3. Okay, so ln, the absolute value of the whole thing, and then a nice little plus c on the end. That is it. That's the question. So we've done partial fractions. We've done a whole bunch of partial fractions here. Then we integrated it, and then we just need to tidy it up because of this. If that wasn't there, this would be just a fine answer, right? This would be a fine answer. But because we're being told very specifically what form we need to give it in, we need to do just a bit extra. All right, celebrate, and we've got one more coming up. So here we come to a pretty tricky question. It says determine the smallest possible value of A, positive value of A, given this is true. Okay, so you should start to develop an instinct for these maths questions, and when you see this big mess here, you should think, oh, okay, I'm going to be able to simplify that. I don't know how yet, but let's have a play with this and simplify until it looks like something I'm familiar with, and I should then be able to start dealing with like integrals and things like that after the fact. So let's look at this. I see a sec and I see a tan. So I know that sec is 1 over something, and I know tan is something over something else, and I know that cosec is something over something else. So I should be able to rewrite all of this in terms of trig ratios that are like fractions and stuff. That'll allow me to start pushing stuff together. So going through it, we've got sec 2x, and that's equal to 1 over cos 2x. We've got tan 2x, and that's equal to sine 2x over cos 2x. And on the bottom, we had cosec 2x, and that's equal to 1 over sine 2x. Right, now I've said this before and I'll say it again. Maths teachers, when they see a question like this, they don't know what they're going to do next. Or they do know what they're going to do next, but they don't know what's going to come after that. So it's not until I see this that I start thinking, okay, what can I do next? Well, I look here and I see two fractions that I can add together. So that feels like the next most logical step, adding those two fractions together. So when I add those two fractions together, the denominator is just cos 2x, cos 2x, cos 2x, and the numerator is just 1 plus sine 2x. Now, in the process of doing that, I think maybe also it would be worthwhile pushing those together into a single fraction as well. So 1 over sine 2x plus, and I can turn that 1 into sine 2x over sine 2x, right? Anything over itself is 1. So that means that this denominator now is going to be 1 plus sine 2x over sine 2x. And all of this, with respect to x, is going to be equal to 1. Wow. Okay, so what do I have? I have a fraction divided by a fraction. Now that's interesting. You will have learned how to do this in like year 9. A fraction divided by a fraction. A over B divided by C over D. that's the same as A over B times D over C, changing the sign and flipping that second one. So what does that mean for us here? It means that this is going to be equal to, and I'm going to do some scribbling and then I'm going to get rid of it because you should be able to do this without all of this stuff. I'm just adding it so that we see it in action. That means that we've got 1 plus sine 2x over cos 2x. And all of that divided by, and so I'm going to turn the divide by into a times not by this, but by the reciprocal, sine 2x over 1 plus sine 2x. Why is this great news? Because these cancel each other out. And so that means this entire mess is just equal to sine 2x over cos 2x. So in the process of writing that, I'm looking back at my work. I'm noticing I've been a bit careless. I've got this bracket here. It's supposed to have a little squared. So squared there, which means that that's squared there, which means that this sine 2x cos 2x is squared as well. Now, you should look at sine 2x over cos 2x, and you should be thinking to yourself, I know what sine 2x over cos 2x is. It's tan 2x. So you can see we've come a long way. We now have 1 plus tan 2x squared with respect to x equals 1. Now, obviously, the entire time you're doing this, you've got your formula sheet open, because whenever you hit a spot and you're thinking, what next? Well, hello, Pythagorean identity. You can see we have tan squared a, which is the same as tan of anything squared, plus 1 is equal to sec squared a. So we can replace all of this with sec squared 2x. All right, I've got it. I'm in business. I'm doing the integral between a and negative a, sec squared 2x with respect to x equal to 1. And you should be looking at integral sec squared, and you should be looking at your formula sheet, and you should be seeing something like this. The integral of sec squared x is equal to tan x plus c. So it's not quite what we want because it's got like a 2x instead of an x, but luckily we can still use like a u substitution to get through this. So we can say let 2x equal u, which means that the derivative of u with respect to x is equal to 2, and we can say that dx is equal to half du. Using this piece of information now, we can put the integral a negative a of sec squared 2x. Now that's going to be equal to sec squared u with respect to u, and we've replaced the dx with half du. So we can take that half and put it right out the front here. Okay, we've got the integral of that. We know what the integral of that is. It's half, and we're going to go a to negative a of sec squared u, which is going to be tan u, and then we don't need a plus c because we're doing a definite integral, so just tan u. But of course u is not u is 2x. Okay, and finally we have tan 2x half equal to 1. Okay, pretty good so far. We're getting very, very close. I see this half here, I see this 1 here. It's probably a good time now to divide both sides by a half. So that's going to make this equal to 2, and I can move that half, get rid of it. And then I'm going to sub a into this and negative a into this. I'm going to actually do it. So I've got tan 2a minus tan negative 2a. And this needs to be equal to 2, and we need to be able to solve that. This question's full of interesting, tricky little bits here. This value here, tan 2a, and this value here, tan negative 2a. Let's just like puzzle out what tan 2a and tan negative 2a, how they're related to each other, right? Remember, everything sort of exists on a unit circle. If we did tan of an angle, right, let's just call that angle 2a, and let's call this angle, right, an equal sized angle but negative, right, the values, the absolute values of those are going to be equal. The absolute values of those are going to be equal. But tan is positive in this quadrant and tan is negative in this quadrant. And even if 2a was a larger thing, it was like over here, right? 2a was here and negative 2a was here. It's negative in this quadrant and positive in this quadrant. So, what am I getting at? Tan 2a and tan negative 2a are related to each other. Tan 2a and tan negative 2a is the same as negative tan 2a. And we're subtracting it, right? Tan 2a is equal to negative tan 2a, and we're subtracting it. So we're left with tan 2a plus tan 2a is equal to 2. So we have 2 tan 2a plus, we have tan 2a plus tan 2a, which is 2 tan 2a. I'll just get rid of these because it looks like I've written a fraction. All right, so I've got 2 tan 2a is equal to 2, which of course means that tan 2a is equal to 1. And now we just need to solve for 2a. Now this is a trigonometric equation you should easily be able to solve. You should be able to say that 2a is equal to pi on 4. And then finally, if 2a is equal to pi on 4, then a is equal to pi on 8. Determine the smallest positive value of a given this is equal to 1. My answer is pi on 8. Are there other answers? Yes, because of the way trigonometric functions repeat on themselves. We could do pi on 8 plus 2 pi, etc., 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 etc. But this is the smallest positive value of a. What a wild, wild question. So that's the ball game. Another week down. That was week 15. Link in the description to next week's questions. I will catch you then. Happy birthday, Jess.